Hello, hi and welcome. Today is a regular recording session after a bit of a break from creating videos since I started working and stuff came up, so I haven't had the time. But as the title says, I recently got access to the Jai private beta, which is very awesome. I really have enjoyed following along with how Jai has been progressing throughout the Jonathan Blow streams, and it's also interesting to me because I really much enjoyed Odin, and from what I've read or heard, Odin is very very similar to Jai, except Jai seems to have a bit more more features, I think. Yeah, so that's what we're gonna do today. Let's make sure this is big enough. So I have I have done a lot of coding in the last couple of days with Jai, so this is going to be my first kind of approach. I can show you some stuff I made. Yesterday I started building this little thing right here. Started building like what I want to be is an Asteroids clone with a couple more features than the original Asteroids, like power-ups and stuff, and some particles and sounds. Just to kind of try out the language and how it feels to make a semi-serious game in it. So that's one thing, and another thing that I've been doing, let's see, we can actually remove this one. No, we can't. I have insufficient access rights. Whatever. Let me think. Yeah, this one. So the first thing I made was this. This thing that just spits out a file, a text file. Oh shit! Now I touched it. Maybe. Yeah, it's empty. But the purpose of this, or the function of this program, is just to generate. Let's put the code here, and let's put this over here, somewhere here maybe some more space for the code. There we are. So the purpose of this program is to generate a text file with today's date and also fill it with a template. So if I had a template here and some content, it would put this content into the note. So just to speed up what I already do daily. And speaking of, I am actually going to create something for today, so I don't forget. Cool. Let's create video. Cool. Put description. Cool. Let's open up a new tab here. Go back into Jai. Yeah. So far Jai has been really good, I think, to work with. It's been really fun. It's quite simple relative to if you were to do C++, modern C++ programming, or Java or JavaScript and all that. It's in my opinion, this has been very straightforward so far. So with that being said, what I want to do now, let's see. So included in the open beta, and I guess this will also be included in the actual release, is a folder called altough, which, as far as I understand, goes through, I'm not sure about the numbers here, but it goes through the main parts of the language. And so far I have been working my way up to, and I think I went through this one. Yeah, I did. So all the way up to polymorphic arguments. So to start, we see how long this takes. I want to go up to polymorphic structs, and go through polymorphic structs, and after that perhaps code some on the Asteroids, the Asteroids clone. So let's see here. Let's start. So we're going to do polymorphic arguments. So let's build it. It's built, and let's just open up the debugger, kill all of those. Shit. Dev jai compiler how to, and 110 exe. Cool. So we have that open, and let's also bring up polymorphic arguments to here. This is just so I can step through the code while also learning. Alright, so let's start. Let's go into the first. Let's actually read the top one first. Wait. Yeah, this is fine. Sorry, go there. So in 100 polymorphic procedures, we show that procedures can be polymorphed when you call them, but this isn't the only occasion when that can happen. A procedure can be polymorphed when it's a parameter to another procedure. Okay. Here's a simple example of polymorphing this way. So a function that takes in a function that takes in a float, that spits out a float, an x, and a count. Apply the function to f to x count times. Okay. Square. Square is a polymorphic procedure, and apply float, which takes in this thing, float can be put into here, and it will be automatically polymorphed into float here. Okay. We can re-polymorph square by passing it as another type. Oh, yeah, makes sense. In principle, you could polymorph procedures during any match operation performed by the compiler, but for simplicity and robustness reasons, right now we limit this to passing polymorphic procedures as arguments only, but we will probably lift this limitation in the future. Oh, but for right now we limit the passing. Okay. Our apply functions above were suspiciously specific, made just for this example. If you want to write polymorphic things, maybe you had to have a polymorphic apply. But if you try to call this with our polymorphic version of square, there is nothing to determine the type. Yeah, that makes sense as well. So square is a polymorphic procedure, and apply one takes in a polymorphic procedure. So the match operator, or the match operation has no clue about the actual type. In this particular case though, we are passing an argument with a concrete type. Yeah, so this one works because the type is determined here, and that one is passed in as a free, so it will be a signed 64 integer, and so the polymorphic type now knows that x is a S64. Then this should print 64, so if we step down to here, run, oh, yeah, okay. X64, S64, makes sense. These examples are a little bit contrived. Much more common is a Lisp style iteration, applying a function to every element of an array. Yeah, so map takes in an array of some type and a function of some type that returns another thing. And it returns an dynamic array of type S. Yeah, so it goes for array, adds to result to run into function. It makes sense. Couple of fruits, an array of strings. We can map the same array for different functions, because our declaration of map allows f to return a type S that is different from T. Then as long as the compilers can solve for S, we are fine. Yeah. So this is all very straightforward, but also very powerful. As I said, this is all very, very, very straightforward. Wait, what is that last thing? So map, yeah, of course. Map x count. Yeah, okay. Quicksort is a polymorphic sorting routine defined in modular sort. Two versions. In the first version we use here, you just apply a little function that maps any individual elements of the array to a number, and it will also sort these numbers from lowest to highest. Yeah. But sorting just by length of the name is not necessarily so good of a criterion, because some fruits have names of the same length. Secondary sort of criterion. Here's a very hack way to do that. We'll map each fruit to a float, the integer part of which is same. Yeah. This worked fine because quicksort is polymorphic. It doesn't care what type the result is, so long as it can compare them. You can also do a C-style sort, where instead of mapping each element directly to a number, you can map a function that compares any two given results. So this is the version I'm used to, where you pass a function that returns a number indicating order. One interesting thing to note about quick procedure is that the return types get inferred from the body of the procedure, which is something we said in the last installment does not happen. This is an exception, but it's not confusing because quick procedure is one simple. Yeah. So these are called quick procedures, and the return type is gets inferred by the body. So here it's inferred to whatever count or whatever this would be, float, I guess. Yeah, float. Cool. Whenever you polymorph a procedure, an iterative solution process happens, wherein the type of all arguments are gradually discovered. This means you can do somewhat complex stuff in polymorphic signatures, like using a type of. Interesting. Yeah. Okay. This is the same map from earlier. Yeah, same. Numbers. Quick procedure. But we get type shipping on the 2nd of stomp. For example, if you try to pass strings, it will not go. Oh, that's it. Okay. Cool. So let me see. Auto bakes. That took a while. That took a little bit more time than I thought. You know what? I think we're gonna do some work on the actual project. I think that's more fun. And right now I want to do something a bit more fun. Let's open up this. Cool. Q. Add this build file, which builds and copies a data directory to a bin file, and so it copies the image and the font, as we can see here, the data directory here. Since the bin file is not committed to the repository, I need to do this. Let's make sure this still works. Yeah, right. So I'm not super sure what we should do next. Either we do the asteroids or we do the shooting mechanic. Either way, we're gonna have to create some images. I think the asteroids would be more fun. So let's draw. I could procedurally generate these asteroids, of course, but I don't want to focus on that. I want to focus on language stuff, and procedurally generating is not that complicated and just involves a lot of for loop some code that I don't want to do. So let's make the asteroids white, and let's increase the size. Not that big. Not that big. Maybe. Yeah, that's fine. And let's just draw something. What does an asteroid look like in Asteroids? There's a couple of different ones. So there's a big, medium, and small variant. This is more like what I want. And yeah, so let's just do something like this. That's okay. That's good enough. And let's fill this. Let's fill this with a gray color. This is gonna make it programmer art-esque. Something like this. And let's add some specs. Maybe decrease the size and decrease the hardness a bit. Yeah. This is super ugly. How do the cracks? How did the cracks? Good enough. Let's make this medium asteroid. And let's see, recently used data. Here. No, not in bin. Here. Medium asteroid. Cool. So we shall have something called medium asteroid texture. Or you know what? Let's do asteroid textures. And make this an array of simple texture. Asteroid 1, small asteroid 0, big asteroid 2. And let's do struct. So this will be type, which is whatever this number is, which I guess is an int. and asteroids will have a position vector 2 and a maybe not this one. Size. Yeah, size. Yeah, actually, I've typed the determinate texture, and then it has position and size and a theta rotation, which will be float. And then we can do asteroids. Asteroids will be a dynamic array of asteroid. Actually, we can have max asteroids. I don't know, 256. And then a live flag. So in init textures, here, asteroid textures, on index, small asteroid, load texture. Let's comment these out and do asteroid will be, what did I name it? Medium asteroid. Cool. So let's have a function called spawn asteroid, and it will take in a type. Yeah. So for asteroids, if it dot alive continue if not, then is there a random module somewhere here? Import random. There is. Very nice. And is there some kind of init function? No. So we need a random state. And this one is in the context. Add context, random state. There's a 0 to 1. Okay. So maybe let's do, for now we can do maybe Let's for now just do 100. Size is also vector 2. 128, 128. And the last one was rotation, right? Yeah. Let's put this at 0. Cool. And we will also do draw asteroids. 4 asteroids. If not alive, continue. Else we should do set shader for images, asteroid textures at it.type. And we should actually just, should we abstract this code? I think we should. Draw immediate at my draw immediate, which will take in, what will it take in? Texture pointer, position, and size, and theta, which will just be float defaulted to 0. Actually, let's not default anything. Simp.texture, and then we can copy paste this code. And we can do here, we can do size.x, size.y. Oh, sorry. Here we can do beta, rotate, pause, immediate, and this will be just texture. Then we could do my draw immediate. Texture would be ship texture, and position would be ship position, size would be ship size. Do we not have ship size? No, we have this, wherever this is. Let's do ship size instead. 32 by 32. And yes, ship size and ship. Cool. Let's make sure this still works before we move on. Oh shit. Yeah, we draw ship. Boom. We can also add draw asteroids here. Build, yes. And bin/main. Cool. So ship still renders. So here, no here. All we have to do here now is call texture will be asteroid textures at it.type. Position be it.position, it.size, and it.fit. Cool. Very good. And here, let's add something. Let's do if key shift for now. What did I name it? Spawn asteroid. Medium asteroid. Type. Yeah. Let's see how this looks. Yeah. Does it really look, or does it look right? I'm not sure. Let's do random here. Random position. X will be random get within range. Let's do 0 to actually 128 to window width minus 128. Random state. Context dot random state. No. Within range. Random state. Oh yeah, this would be, of course. Yeah. So this is a new thing added recently with the postfix casting. So dot and then the type you want to cast to. So if I were to do like dot this, it would complain because I don't get reasonable errors here. Float pointer, or if you do sign 32, but yeah, we want dot. We want to cast a float. So yeah, shit, of course we have to use these positions here. And build and run. Whoa. Oh. Yeah, so now we instantly fill up the array here. Because we're only doing key pressed. So this is where I have to actually look into the code from examples, which I luckily have some example to follow. So in the examples folder in Vaders, if we open this up, this is what I kind of based my original setup on. And in here they have, let's see, somewhere down here, shift, shoot button down. Let's see how they do. So shoot button down, maybe fire bullets. So they have a cooldown here. What should we do? Let's see, update keys, events this frame, returns an array of event. Repeat. Maybe repeat is the one we should look at. So no, actually this can be so wait. So repeat is a boolean. So op and not event dot repeat. Yeah, now we need to go back to our build and run. Yeah. Still doesn't work. Let's do this another way, and let's do the casting with postfix thing. I think it looks better. This reads very easier, I think. So here, let's add something called simulate asteroids. Am I thinking here? Simulate asteroids. No, it's just not wanting to work with me. Yeah. Let's restart jails. Yeah. Here. Let's move this down. Keep the constants up here. So what I kind of want to do is let's keep a timer on. Let's call this time until asteroid spawn. Every 4 seconds. And in here, let's do time until is minus equals delta time. Oh. This should be a float. And here, if time until asteroid spawn is less than 0, and we do spawn asteroid, and then we do time until asteroid. Yeah. No. Build. So every 4 seconds. Every 4 seconds it spawns a whole shit ton. Wait. I think I know what's wrong here. And maybe you saw this before I did. Break. Yeah. Yeah. Cool. So now let's think about this. We want them to move. So we want to spawn them outside of the window and point them towards the player, I think. Or if we spawn them outside the window and then just point them towards the center. And maybe some kind of like, so towards the center. I should probably just look at the original game, but I don't know. Whatever. So we spawn them outside here. This is an asteroid. And this is another asteroid spawned outside the window. Somewhere. Yeah. So the initial velocity, or their velocity, will just be pointing towards the center. So they will come in. And this one will go sort of right through here. This one will go kind of like this. And if one were to spawn up here, it will kind of go through here. We could also do maybe some sort of random-ish rotation of this vector. So it will point to center, normalized, and some kind of rotation. Some kind of random offset. It could even be, so let's say this is the player, and let's say here's the center part. Here's the center. It could be that we calculate a vector towards the center and also a vector towards the player, and then we pick a random angle between these two. So there will never be an asteroid that just spawns and just never is even close to the player. There will always be some amount of close to the player. Yeah, but let's start by doing the simple one, which is point towards the center. So we will introduce to the asteroid a velocity, call it vector 2, and in the simulation, we iterate through the asteroids. If not alive, skip, and the position will be plus equal their velocity times delta time. So give the it here will be pointer, so we can modify. And what we could we do this, or maybe no, maybe this, no, whatever. And when we spawn an asteroid, which is here, this is where we will have to set the velocity. Let's do a thing called get random point outside of play area. Takes in nothing and will give out a vector 2. And so we'll have to pick side first. So random number. This is float. Let's do random 0 to 1. Huh, yeah, random 0 to 1. And if side, you can't do equal here. And then instead, if we do get within range 0 to 4. I'm guessing, yeah, max and min are both inclusive. So if we just do a float, is a float 32. What is the max value? Float 32. Actually, we can safely cast this to a U8. So remove the decimals, inclusive from 1 to 4. No, actually 0 to 4. So we will have either 0, 1, 2, or 3. Ugly. This is kind of ugly, but yeah. So now we can do if side is equal to, and then we can do 0, 1, 2, 3. We can do case here. So if side result return result, so 0, let's say this is the left side of the window, and then result.x will be minus whatever the biggest size of the asteroid is. Let's do 256, and the y will be random get within range, and so it will be can't be 0. We should actually pass in the size here. size of x, and so this would be from fin size dot y to screen window height minus fin size dot y, and this will be right side. So pretty much this. Oh fuck. Same x. No, not same x. X. Screen window with same y. This is a that, and this would be top side. So x will be zero to window with minus fin size of x, and y would be window height plus fin size dot y. And last one, bottom side. So same x, but the y will be 0. Cool. So we can remove this. And here we can just do get random point as a player, and fin size would be whatever this is, size 8 through 2, 128, 128. Then this one can also be size, and pass in velocity, and velocity will be we have to retrieve the position outside of here first. So position. So velocity would be a vector pointing to center. So center position is just to window with and window height divided by 2. That's our center. Center minus position. Is there a normalize function? Yes, there is. Normalize center minus position times something. It's 200 for now. that's it, I think. Because here we do the update of the position. So let's try this. Let's see. Yeah, so what we should do, let's debug this, because debugging is super fun. Oh, god damn it. God damn it. Add target. Sorry, I'm being dumb. We need to add the exe file. And then we need to add the source file. Here, and let's remove all these breakpoints, and somewhere here. Yeah, so this looks right, because position is good, 0 and 760. And velocity should then be positive in the y direction and negative on the x. Yeah. So why is this not working? So let's increase this and let's see how this looks. Yeah, they are not moving. And they're also spawning very weirdly. 3. Weird. Mm-hmm. Three 3.6. It's a little confusing right now, actually. Let's check if we get 3.6 every time. Oh, no, this is that's problematic. Yes. .6. So we are getting random, the same random value every time. Maybe we need to seed this random thing. So maybe we need to, let's see, down here. Huh. U64. Okay. Sorry, this is not ideal right now. I have to check the code. This one. Since I am current time returns Apollo time. Current time consensus. And what the hell? What the fuck does this return? Apollo time. Actually, I need to go. I need to do Apollo time. A real-time journey for this Polynesian website. I have no clue what Apollo time is. Apollo time represents a time in objective reality. It does not get adjusted based on what time zone you're in. Adding and subtracting hours to Apollo time is not the right way to implement time zones. If you do this, you are inviting weird bugs and generally asking for trouble. Yeah, we can't cast this, but what we can do is get calendar. What is it called? Fuck me. Sorry. To calendar. Okay, let's remove this. Let's do. Let's see, it will be to calendar. Current time. Okay, so let's see. Let's see. And build. See this 476. That does that make sense? Yeah, okay, so it's a random number. That's good. Yeah, and our result is something different. So now we're getting left side. Yeah, so now it's definitely outside the window. And now velocity is pointing down. So position is kind of freaked up here. 8552. Let's iterate. Same velocity, so we are, and oh. I saw the bug. Yeah. Sorry. But at least we fixed this, which we want to do somewhere up here. Here. So at least we fixed this random thing. And oh, let's build. And let's run. So now it's oh. Yeah. let's make sure. So that seems to work. And let me go down here somewhere. Simulate asteroids. Let's not move them. And let's here. Let me put this back. So maybe every second. Let's just make sure that no asteroids are spawning inside of the map, which they are. Interesting. It looks like half the image is showing for some reason. But that only seems to be true for the bottom and right side. So the bottom and right side. So right side, X will be window width. So it's almost like they are rendering at double the size. And that would make sense because properties. This one is 256. Yeah. And here we are putting size at 128, so half the size. And they're being rendered at their size. Size.x, size.y. But so I guess this bug will disappear if I do this, right? No, same bug. Same bug. Size. Window width dot float right side and bottom side 0. Why is this not working? So if I were to do a size of x here, and minus full size of y here, they don't show up anymore. Weird. Right side is 1. So if I do divided by 2, window width is 1/200. Weird. I'm not super sure why this works, but let's move on for now. And this problem will probably come up later again. But for now, let's focus. And here. Yeah. Cool. So that sort of works. And the last thing I want to do is actually just add some kind of angular velocity to this. And in the simulate asteroids, I want to do. Let's bring this back to the pointer. And let's do. Theta plus equal to it dot angular velocity times delta time. And here we can pass it in, so angular velocity is get random within range, and let's do minus 50 to 50. Like so. Build. Beautiful. Beautiful. Cool. So next up is probably either collision between the player, just general collision, I think. Or maybe we do bullets first and then we can do all the collision between bullets and asteroids and ship. Cool. So we have been going for 1.5 hours. And I think we're gonna end here. The debugger I've been using is the RAD debugger, which is not released as of yet. If you Google RAD debugger, comes up. But yeah, for the purposes that I'm using it for, I could have just as well used either GDB or Visual Studio Debugger. I just like the UI in here. It's pretty straightforward. Yeah. Let's close this down. And let's finish off by committing this. So let's call this Asteroid spawn and movement. Done. Finish. I might actually think about, so if we just for fun open up a new, no, let's open up a new, it's 128 and transparency. So let's So window, dockable dialogues, tool options. So if we were to make this the asteroid circles instead, and then we could maybe do some kind of something like this. That's an ugly fucking asteroid. Maybe something like this. And maybe let's draw in some kind of white outline to this. I'm sorry, this is super off topic. Let's kind of do this. So this is pretty close to a circle, and then we could do a collision with the circle, which is much easier to code. Much more straightforward to do collision between a, let's say, rectangle and circle. Since you only need to check the, see, if you have a rectangle, you have the left, like the min and the max, and we just do collision. Check if any of the points are, the distance between any of those points is less than the distance between those points to the center of the asteroid is less than this radius of the asteroid. Then we have a collision. I think that's how I do it. Collision between rectangle and circle. We can treat our ship as, oh, maybe there is something rectangle, triangle, or rectangle. Maybe we can do something like this. Circle intersects edge, that's what we would want to do. And we could pre-calculate the edges. No, we can't. We can't do that. They will change with rotation and position. Yeah. So we could do this. And I think that's what we want to do. So I'm gonna draw 3 different sizes of asteroids with 3 different radiuses, and they're going to be kind of close to circles. There will be some error, but that's fine, and that should be good enough. And for the like the bullets from the ship, we can just do a point inside circle. That's good enough. Which is also super simple. Cool. All right. Thank you if you kind of watched this thing. So this has been Jai, and if you think this looks fun to code in, I can recommend, since you can't get access to Jai simply, you can email just as I did and see if you get into the closed beta, or Odin if you want to try out a similar language, at least syntactically. In the syntax it's a bit similar, but Odin has some fun stuff on its own. Alright, thank you for watching, and I think next session will either be continuing on this, or I will continue on the clay tutorial. I think I kind of finished up the clay application. The rest that I wanted to do is focused on using Raylib and creating an actual game. So that's not super relevant to the actual clay framework. So we'll see if I ever get to that. Alright, bye bye.